These are two robots playing rock, paper, scissors like you've never seen it before. Whoa, that must have hurt. Just kidding, robots don't feel pain. Trust me, bro. It's rock, paper, scissors with giant fighting robots built in Fortnite using UEFN. I used an AI tool to animate the finishers, which is a super fun workflow that I want to share with you. This is not gonna be a step-by-step tutorial. It's more of a breakdown and maybe inspiration for some of you. You ready? Let's get into it. In Fortnite you play 1v1 and you have to pick rock, paper or scissors each round. For that you have a separate area where you can make your selection using the default Fortnite switches. When the round timer runs out, the big mech robots act out the moves based on your selection and it's visualized like a battle show. When someone wins, an epic finisher cinematic based on their move gets played. When you've won using rock, the robot punches the other robot in the face. When you've won using paper, the robot uses a karate chop. And when you've won using scissors, the robot uses a two-finger jab into the other robot's eyes. Every player has 3 lives, symbolized by the 3 hearts on top. The first player to lose all of their lives loses the game. The map is sci-fi themed and gives futuristic battle arena vibes. It's based on the robot character design, which was part of the limited time free content on Fab. The sci-fi environment is from Fab as well, and I adapted it a bit to fit the gameplay. You have a separate area to make your rock, paper, scissors selection, and you have windows to see into the battle arena and also see the other players, so you can use emotes to taunt the other player, for example. It's a round-based system with a timer that counts down each round. There's a clear visual feedback and the player should always know what's happening. I wanted it to feel like a live show that could stand on its own, not just another minigame. Each winning move triggers a unique finisher cinematic. For rock we have the punch, for paper we have the karate chop, and for scissors we have the two-finger stab. I used Sequencer to time the animations and create the camera moves. Sometimes I had to adapt the placing of the jumps and the reaction to the finishers a bit. I also created some custom particle effects like this motion trail to make the hits more impactful. If you'd like me to do a tutorial about any of this specifically, let me know in the comments. For the rock, paper, scissors game animations, I worked modularly. I have one sequence for each move for each robot, and another sequence for the camera moves, and Verse then plays them together correctly based on the player selection. To complete the sci-fi look, I even created a custom bokeh shape for the lens flares. The default lens flares didn't fit the look I wanted, so I made my own. You can just set it up in the post-process settings. Now let's talk about how I created the epic finishing move animations. Quickmagic, a company offering AI mocap solutions, reached out to me about testing their tool and doing a video about it. This is not a sponsored video, but I did get special access and some account perks as well as a referral code for when you create your account there. The tool turns regular video into 3D animation, no mocap suit needed. It also only needs one camera instead of multiple cams like similar tools. I didn't just want to create a video doing some random movement and creating an animation with no context. I had the idea with rock, paper, scissors with giant fighting robots and thought this would be a perfect fit for that. So I recorded myself doing the rock, paper, scissors moves, the punch, the stab and the karate chop. I uploaded it to Quickmagic and got the 3D mocap animation downloaded from there. Let me quickly show you how to use the tool. Once you're logged in, you can upload a video to the site. It will automatically detect a person when it sees one. And down in the bottom you have a timeline where you can scrub and also trim your video if you want to. Here you can see me awkwardly jumping around in my room. You can then select the output format by dragging and dropping it onto the person in the video. This is basically the skeleton the animation gets baked to. You have a lot of different skeletons to choose from, including the Unreal Engine 4 and the Unreal Engine 5 mannequin, which is currently in beta. Then you click on Next and you can choose how the motion should be generated. You can choose from full body, only upper body, including the hands and face. I chose to include the hands since I wanted the rock, paper, scissors poses as part of my animation. If you have started your video with a T or A pose to better calibrate the motion capture, you can select this here. Otherwise, you can just select original pose like I did here. There's also an anti-interpenetration feature, which I guess should prevent the body parts from clipping into each other, but I haven't tried that out. It tells you your export format again, as well as the cost for the motion capture. The system works with credits and it depends on how long your video is and what type of data you want to have extracted from it. Once you click Generate Now, it will start analyzing the video and generate the animation from it. When it's finished, you can watch it online in a special viewer that shows you the animation and the video at the same time. From there, the animation can also be downloaded. I downloaded the animations and brought them right into UEFN. The mocap data is a very good starting point. I'm impressed. Even when my foot was shortly outside of the frame, there was no flickering, no weird movements in the 3D animation. Even the hand poses and the finger movements are not too far off, especially for using only one camera. No matter where you get your mocap data from, there's always a bit of cleanup needed to fit your project or your environment. I only did minimal cleanup for this project. I also created only one rock, paper, scissors movement animation and then adapted the hand poses in UEFN using Control Rig. Quickmagic is a great tool to quickly get movements from your brain to your body into your virtual world. No matter if you're using Unreal Engine, UEFN, Unity, Roblox, there are many different skeletons and export formats to choose from. If you want to use it or try it out, check out my referral code in the video description. Thank you. As previously mentioned, I used Sequencer for all of the cutscenes. For the live UI, I used a stat creator device combined with a custom UMG widget and a custom material. In the hearts material, I made use of some of the material functions from the UI material lab to create the animations. I also created two states, one active, one inactive, to show if a life has already been lost. The state transition from active to inactive is a UMG animation, which is triggered through view bindings. Of course, there's also some verse involved for the game mode, the round results, and the triggering of the cinematics. I also used the Epic Developer Assistant for the first time as a base code for the round result comparison. For those of you who don't know, the Epic Developer Assistant is an AI that helps you create verse code with the use of prompts, and you can also ask it for support for UEFN related questions. You can check it out with the link in the video description. So, I used the simple concept of rock, paper, scissors and turned it into an over-the-top sci-fi mech battle using UEFN. This is how flexible Fortnite has become as a creative platform. I also tried out something new with the Quickmagic AI mocap tool, and it's surprisingly fun and useful. I hope this sparks some ideas for your own creative projects. Try the rock, paper, scissors map out yourself. The island code and the link is in the video description. Go play it with a friend and tell me what you think. Please also try out Quickmagic with the link and my referral code. Thanks. Like, share, subscribe, comment, do all the things. Thanks for watching. See ya.